So we are going to work out the Module 4 practice test. And don't you guys just love Module 4? All reading, number sorting, okay. Alright, so number 1. When we take a census, we attempt to collect data from, well, basically when you see that word census, you're thinking that you're going to collect the data from the entire population. So you want to kind of look through here, and which one would that be? Well, that would be C. The census means that you're getting data from the entire population. That's what a census is. All right, you want to take a simple random sample of 50 of the 816 students who live in the dormitory on campus. And you're going to label the students 001 through 816. And you put them in alphabetical order, and then you're going to use the table of random digits. And then the first 3 students in your sample would have labels of what? So think about this. If I had selected digit 002 and 002 again, that's the exact same person. So that one would not be included. Or if I had the digit 000 or 817 or above, those are not included as well. So as we go through this list, we need to make sure we don't have repeats and we don't have numbers outside of the range listed. So the first digit, the 955, well, we wouldn't use that one. The next one is 929. Wouldn't use that one. Those are both outside. So 400 is the first one that we would use. Then it goes 769. That looks good. Then it goes 769 again. Well, that's the repeater. And then it says 335. So the 3 that we would use would be the 400, the 769, and the 335, whatever those people represent to. All right. So weird. Next one. Sorry, you're not weird. This board is acting up this being really weird. Sorry about that. Okay, a study of treatments for angina, which is pain due to low blood supply to the heart, compared bypass surgery, angioplasty, and use of drugs. The study looked at the medical records of thousands of angina patients whose doctors had chosen one of these treatments. It found that the average survival time of patients given drugs was the highest. What do you conclude? So I'll let you kind of look over those again. And what is it that you can conclude? Well, did you perform any treatments? Like, were you administering anything on here? All you did was observe what had happened. So if all you did was observe, then this is going to be an observational study. So in this case, it would be D. Okay, number 4. A simple random sample is, and this is really important. If you didn't get this right, you really need to know what a simple random sample is. It's not just any sample. It's very specific. So the correct answer here on number 4 as you're looking through is going to be C. Okay, so it's a sample that gives every possible sample the same size. So like whichever size you're picking, every possible sample could happen at the same chance. Okay? So really know what an SRS is. That's simple random. Okay. Number 5. And I gotta move over here to extend the page. Something's not communicating today. Alright, number 5. Consider an experiment to investigate the effectiveness of different insecticides in controlling pests and their impact on the productivity of tomato plants. What is the best reason for randomly assigning treatment levels, spraying or not spraying, to the experimental farms or sorry, the experimental units, which are FARs. Okay, so again, when you're kind of looking over here, you have all of these FAR and the crops going on. So as you're taking it, you want to try to get in the same positions things going on, right? So you're trying to like randomize so that all of the things going on with fertility, maybe the soil's better in one area than the other, just maybe the sunlight is hitting something better than the other. But for this guy, number 5, the answer is going to be B. Random assignment will tend to average out all the other uncontrolled factors, okay, such as that soil fertility, so that they are not confounded with the treatment effects. So our number 5, our right answer is going to be B. Okay, number 6, the most important advantage of experiments over observational studies. Well, if you're just observing, then you cannot have causation. So if you have an experiment, then you can see what causation. So in this case, we are going to have B. Okay. Number 7, this is the good one. A TV station wishes to obtain information on the TV viewing habits in its market area. The market area contains one city of population 170,000, another city of 70,000, and 4 towns of about 5,000 inhabitants each. So you have all of those areas. You have the city of 170,000. Then you have another city of 70,000. And 4 towns of about 5,000 each. Okay? So that's kind of what's going on. The station suspects that the viewing habits may be different in larger and smaller cities and in the rural areas. Which of the following sampling designs would give the type of information that the station requires? So hopefully as you're looking through here, you're thinking, well, it's either a cluster or it is stratified when I have all of these groups going on. Okay, if you didn't get that far, we can talk more, but hopefully you're looking through and you're thinking one of those two. So what's the difference? So within a cluster, you have like all of those different groups, and you do an SRS and just pick like so many of the groups. So you may pick just 2 groups total. So if we were to do this in this case, and only pick like those guys, are you going to get a good representation of all the different areas? Absolutely not. So over here in stratification, you're going to have all of those clusters, and you're going to do an SRS within each of the clusters. So that is going to be what we would like. So 7 would be D, because we would take all of these different towns, cities, whatever, and do a little SRS within each of them. And hopefully you pick proportional. SRS, you pick proportional to the population of that city. Okay. 8. Bias. Okay. So basically, when you think of bias, you should think of things happening from a non-random process. Okay. So on 8, it's saying bias in the sampling method is what? So in this case, it's going to be D. It's any systematic error that tends to occur in the same direction whenever you use the sampling method. I don't know. We can talk about that more. You can email me if you're confused. But with bias, if you're looking through here, that's going to be the only one that's going to represent that definition. Okay, 9. You wonder if TV ads are more effective when they are longer or repeated more often or both. So you design an experiment 30-second and 60-second ads for a camera. Your subjects all watch the same TV program. You assign them at random into 4 groups. One group sees the 30-second ad once during the program, another sees it 3 times, the third group sees the 60-second ad once, and the last sees the 60-second ad 3 times. You ask all subjects how likely they are to buy the camera. So then it's asking you, well, what kind of design is this? Okay, so look over those. It is randomized, so we're good with that. But then we have some things that could be as well, so randomized, so we're kind of looking at C, D, and E. Is there 1 explanatory variable, 2 explanatory variables, or 4 explanatory variables going on? So in this case, we have the 4. We have that 30-second once. We have the 30-second, what they say, 3 times? 3 times. We have the 60 seconds once, and the 60 seconds 3 times. So this was, the correct answer was the E. Okay. 10. A researcher wishes to compare the effects of 2 fertilizers on the yield of soybeans. She has 20 plots of land available for the experiment, and she decides to use a matched pairs design with 10 pairs of plots. To carry out the random assignment for this design, the researcher should do what? Okay, so as you're trying to get those plots, you are wanting to get the same pairs, okay, as you're doing the 2 different treatments going on. So you want them to have as equal amount of sunlight or as equal amount of soil fertility in both of the treatments. So you want to try to get as much as possible the same pairs. So in this case, looking at those, the only one that would really work for you is B. 11. You want to know the opinions of American high school teachers on the issue of establishing a national proficiency test as a prerequisite for graduation from high school. You obtain a list of all high school teachers belonging to the National Education Association and mail a survey to a random sample of 2,500 teachers. From the sample, 1,347 of the teachers returned the survey. Of those who responded, 32% say that they favor some kind of national proficiency test. Which of the following statements about this situation is true? Woo! Okay, so looking down here, I can see as I'm talking that this has to do something with a non-response. Okay? So you have the non-response because not everybody mailed them back to you. So basically, just the people who are mailing them back to you are the ones having a more strong opinion. So you're going to have some bias going on from those who don't have as strong of an opinion. So the one that would do this, work best for this situation is E. Okay, response. We're going to go ahead and just do this all in one. So, elephants sometimes damage trees in Africa. It turns out that elephants dislike bees. They recognize beehives in an area where they are common and avoid them. Can this be used to keep elephants away from trees? Well, a group in Kenya placed active beehives in some trees and empty beehives in others. Will elephant damage be less in trees with hives? Will even empty hives keep elephants away? Researchers want to design an experiment to answer these questions using 72 acacia trees. I really want to know the results of this survey. I would not want to be the one that got on beehives, but. So, part A says, identify the experimental units, treatments, and the response variable. treatments. That might be actually the easiest way to start deciding. So all of my treatments that I'm doing is I'm either placing an active beehive, a non-active beehive, or no beehive. No beehive for you. On the what? What are you placing them on? Those are your experimental units. You're placing them on the 72 acacia trees. 72 of them, I think. That worked out good. Yeah, 72. And what's your response variable? Well, after you place them on there, you're going to see what? Well, you're going to see if there's tree damage by the elephants. And again, I really would like to know that. Doesn't tell us. Okay, part B. Describe how the researchers could carry out a completely randomized design for this experiment and include a description of how the treatment should be assigned. Even if, you guys, even if it didn't say that last sentence, you should always explain how you're picking your SRS. Okay, you need to thoroughly explain that. That's really important. So if all you do is tell me, oh, I'm going to do an SRS for 3 groups of trees. Yeah, that sounds good. No, that is not good. Okay, that is not enough. You need to explain how are you getting your SRS. Okay, so let's see, there's 72 different trees. So you could assign digits like 0, 0 to 71 or 0, 1 to 72. However you want, assign those to your trees. Okay. Then you may, I don't know, you could have your calculator do the random digits. You could do a random digit list of numbers. And you have that in your book as well, like notes. So you need to say how you're going to do that. You're going to put all those numbers in a hat and pick them out, okay? And the first, you could say the first, what's 72 divided by 3? So the first 24 get the active beehives. The second 24 get the non-active. And the third group of 24 would get no beehive. Beehive for those people. Okay. So be really specific when you're writing this out and don't just list it like I am. Write sentences. Okay? But be specific. Okay, so then you're going to have them all in those 3 groups. So each group gets the treatment. And then what do you want to do after you get treatments? Well, you're going to compare all the damage. From the elephants. I just want to draw a picture of an elephant on here for some reason. I don't know why. I don't even know if I can do an elephant. That's horrible. Okay, so oh, I forgot the big trunk. Maybe that one. Okay. So that's what you would do. All right. You're thinking, oh my God, what's gross? 13. Let's get that elephant off there. I don't want to see that anymore. That was horrible. A 2008 New York Times article on public opinion about steroid use in baseball discussed the results of a sample survey. The survey found that 34% of adults think that at least half of Major League Baseball, MLB, players use steroids to enhance their athletic performance. Another 36% thought that about a quarter of the Major League Baseball players use steroids, and 8% had no opinion. Here is part of the Times statement on how the poll was conducted. The latest New York Times CBS News poll is based on telephone interviews conducted March 15th through March 18th with 1,067 adults throughout the United States. The sample of telephone numbers called was randomly selected by a computer from a list of more than 42,000 active residential exchanges across the country. The exchanges were chosen to ensure that each region of the country was represented in proportion to its population. In each exchange, random digits were added to form a complete telephone number, thus permitting access to listed and unlisted numbers. In each household, one adult was designated by a random procedure to be the respondent for the survey. All right, now that is a word problem. Part A. Explain why the sampling method used in the survey was not a simple random sample. So that's where we talk about simple random sample or multiple choice. So in this case, not all samples are possible. So for instance, given the method that they had, they could not have had all respondents from the East Coast. Okay, B. Why was one adult chosen at random in each household to respond to the survey? Well, I don't know. Let's say the people who answer the phones all the time. Let's say it's more likely that it's just a female. Females, let's say, are more likely to think that they use steroids. I don't know. But you just want to make sure that you control for any of those working variables. So adults who answer may always have a certain response. Okay, so you want to make sure you control for that. And part C, explain how undercoverage could lead to bias to the sample survey. So I see a couple things for undercoverage. So the first one is cell phone users. And the second one is for the homeless. Homeless or those without phones at all. So how could that lead to bias? Well, let's say that cell phone users are a younger population, and the younger population maybe tends to think one way over another. Or again, those without phones are homeless, and homeless people think to go one way or the other on this survey. One more on this wonderful word problem module. 14. Many people start their day with a jolt of caffeine from a coffee or a soft drink. Most experts agree that people who take in large amounts of caffeine each day may suffer from physical withdrawal symptoms if they stop ingesting their usual amount of caffeine. Researchers recruited 11 volunteers who were caffeine dependent and who were willing to take part in a caffeine withdrawal experiment. The experiment was conducted on two two-day periods that occurred 1 week apart. During one of the 2-day periods, each subject was given a capsule containing the amount of caffeine normally ingested by that subject in 1 day. During the other study period, the subjects were given placebos. The order in which each subject received the 2 types of capsules was randomized. The subjects' diets were restricted during each of the study periods. At the end of each 2-day study period, subjects were evaluated using a tapping task, in which they were instructed to press a button 200 times as fast as they could. Okay. How and why was blocking used in the design of this experiment? Alright, so how are you blocking? Well, this is definitely going to be a matched pairs, right? And you're pairing with their subs. About how they're doing with the with the caffeine pill versus the placebo pill. Okay? So you're kind of looking at the difference between each person. Because one person may just be able to cut the test faster, regardless of what's going on. It may be a little slower or something, but they may just be able to tap faster. Better reflex. I don't know. Okay? So thus you want to kind of block by individual dexterity, like how fast they can do it. You like those big words? There we go. But individual differences in dexterity. And B, why did researchers randomize the order in which subjects received the two treatments? So it could be that, like, if you always did caffeine, placebo, that it would tend to be a certain pattern, and you wanted to get away from that. You wanted to make sure that all of that was randomized. So you're going to randomize control for any possible influence the order of treatments and the tapping speed. And last one. Could this experiment have been carried out in a double-blind manner? Absolutely, and I hope it was. Okay. So double-blinded means that neither the person administering the drug or the person taking the drug knows what they are taking. So this could be yes. Okay. Neither researchers nor people in the survey, the volunteers, needed to know what treatment was given until after gathering all the data. Okay? So you could have a third party involved in making sure that those researchers did not know. All right. Hope you do good on this test. Make it in.